Okay, so we're working on operations of functions. So we're continuing on with our function notation that you learned in Math 10 and just looking at all the operations with functions, which we kind of started on last semester, and then looking at composition of functions, and not today, but in the next lesson. So everything to do sort of with functions and inverses as well. I guess we'll do the next day. So we've learned about a bunch of different types of functions. Some are listed there. And now we want to know how to combine them through operations and composition. So just look at the notation. So this notation in the middle column is basically the short form, right? So here, that's a faster way of writing f of x plus g of x. So it eliminates a couple of brackets, basically. And then f minus g is the short form. And then f multiplied by g, or fg of x. So just be careful on this one. That means f of x times g of x. You will learn about composition of functions, where we'll have an open circle between the two functions. This is a dot, a multiplication dot, okay, or nothing in between. And then division, f divided by g. Obviously, with division, we do need to be careful about non-permissible values, right? So let's take a look here. Got a graph. These are continuous functions. They may, you'll notice that g is only defined for certain values, but it's continuous for those values. And so we want to use the graph to find the values on the right. I'm just going to minimize this a little bit. Oh, that didn't do it. Okay, so that just gets it all on. Okay, so this f plus g of 4 really means f of 4 plus g of 4. But I'm not expecting you to write that out, okay? So you're going to do this basically in your head. So you want to look at the f graph when x is 4, y is 3. The g graph, that's negative 4, and you add them together. So 3 plus negative 4 is negative 1. Subtracting, so this is the same as f of 3 minus g of 3. So when x is 3, f is 4, and then g is negative 2. So when you go 4 minus negative 2, you get 6. And then switching those around would be negative 2 minus 4 is negative 6. So that makes sense. The order switches, so the sign switches. Multiplication, so at x equals 6, f is negative 5, and g is negative 8. So negative 5 times negative 8 is 40. F divided by g at 7, so f is negative 12. G is negative 10, and just reduce that. So that was the 6 over 5. Then same, but at x equals 5, f is 0. G is negative 6. So 0 divided by negative 6 is 0. So whenever your numerator function, if you're looking at the x-intercept, your answer is going to always be 0. Okay? Be careful, though, if the denominator is where it's 0, then it's going to be undefined. So that's going to be the next one here. So if we take a look, it's for the same x value, right? So this is going to be negative 6 over 0. So this is undefined. So if we were to graph the whole function, g divided by f, then we would have an asymptote. Well, we'd have, we're dividing by f, we'd have 2 asymptotes. And then multiplication, f times g at x equals 2. So f is 3, g is 0. So 3 times 0 is 0. So if any one of the functions is 0, the whole thing will be. And then f plus g of 0. So at x equals 0, f is negative 5. But notice there is no point on g. So this we can't, so this is negative 5 plus we don't know. So this does not exist. So a short form for does not exist is DNE. You could also put undefined. Okay. So that is basically function notation, all the individual parts. You've done all of that before in Math 10. Now we're just putting it together with the operations. Then state the value or values of x so that the multiplication of f and g equals 0. So think about the zero product property. So therefore, either this is what it means the long way. So either f of x has to equal 0 or g of x has to equal 0. So you want to look at your f, what value of x makes y 0? So that's 1 and 5. And then in your g, what value of x? That's 2. So there's 3 values, 1, 2, and 5. Now, the domain. So if we were to graph the whole thing. So what you want to think about is, I always look at the domain of each of them separately. So f is the parabola. So for f, the domain is all real numbers, right? And then for g, the domain is x greater than or equal to 1. Okay, so remember when we did this last one, we couldn't come up with a value for x equals 0. So when you're adding the functions, which is the first one, we can only add if x is greater than or equal to 1. So this one kind of wins out. Actually, we just need the inequality. So whatever the overlap is between the domains, that's what the domain of the operations is going to be. So, let's change that. So the domain here will be x greater than or equal to 1. When we subtract them, the same. When we multiply them, the same. When we divide them, so think about dividing, excuse me, we can't divide by 0. So you want to look at, so our domain is the same, except remember when g has a y value of 0, so that's x equals 2, we would have an undefined, okay? So here we're going to have to say all values of x where x, so you could, the fastest way would be x greater than or equal to 1, where x not equal to 2. You could split it up into greater than or equal to 1, less than 2, and then greater than 2. This is probably just as easy. And then g of x, same thing. We've got to start basically with x greater than or equal to 1. And then when is f 0? So we already had one of those here at 5, and then also at 1. So because our domain is greater than or equal to 1, but we can't have 1, so it's going to be easier to say x greater than 1, where x cannot equal 5. Or again, split it up into 2 inequalities. So x greater than 1, x not equal to 5, and then x element of the set of rows. Okay, so that's when you combine the functions. All right, discrete functions. So that was a graph. Now we'll look at discrete. So we've got h and m, And we need to do the same thing, evaluate each of them. So this means what's h of 4 plus m of 4. So you look at h, when x is 4, what's y? Negative 11. M, when x is 4, y is 3. So that's negative 8. Then next one, m of 0. So m of 0 is negative 3 minus h of 0 is 2. I didn't really need brackets in that one. I thought it might end up being negative. Then this h of 3 is negative 8 minus m of 3. So m of 3 doesn't exist. So this does not exist. H of 2 is negative 5. M of 2 is 0. So that's 0. H of negative 4 does not exist. Okay, m of negative 4, you can stop there, but it would be negative 9, so this does not exist. M of negative 2 is negative 6. H of negative 2 is 8. Just reduce that. Okay, so that's some of them. And then it says state the domain. So, again, what I'm going to do here is just list out my domain. First of all, so negative 2, negative 1, 0, 1, 2, 3, 4. Remember, this is discrete, so you just list the values. Do not use an inequality. Okay, so state the domain when you're adding them together. So, again, the domain is where they overlap. So we need to know where they overlap. So the negative 2's, the 0's, the 2's, and the 4's. Okay? So that's going to be our domain for all of these, unless we're doing a dividing. So this is going to be negative 2, 0, 2, 4. This will be the same. This will be the same. And then we need to check here. So when do we get a y value of 0 for m? So you want to look up here. There's a y value of 0. When does that occur? When x is 2. So we cannot have x being 2. All right, so that means our domain would be negative 2, 0, and 4. And then vice versa, where do we get a y value of 0? In h. So you look along for a y value of 0, and there aren't any. So this is going to go back to negative 2, 0, 2, 4. Okay. So given two functions, f of x and g of x, the domain of their sum, difference, or product are all the values of x that are common to both f and g. Domain of the quotient are all the values of x that are common to f and g, but excludes value where g of x equals 0. The non-permissible values. Now we've got some equations, f, g, and h, and p. Determine a simplified expression for each of the following and state the domain. So this is going to be 4x squared minus 1 plus 2x squared minus 7x minus 4. Collect like terms. In terms of the domain, so here f, that's all real numbers. G is all real numbers. Let's just do all of them. H is all real numbers. And so is P. Okay, so when we're adding like anything except for division, it's just going to be all real numbers. Okay, so all right, so then G minus F. So I'm going to put brackets so that I make sure I get the signs correct. all real numbers. Then multiplication of f and p Oh, I didn't have to, there's nothing to collect there. Okay, that was done. And then f times g. And what was g? Okay, so 8x to the fourth minus 28x cubed minus 16x squared minus 2x squared plus 7x plus 4. Then collect like terms. You can pause the video whenever you need to. Hopefully I don't make any mistakes. Sometimes I do, so just let me know if I've made a mistake. Okay. And then g, okay, I'm going to have to copy, okay, so g, 2x squared minus 7x minus 4. So 2x squared minus 7x minus 4. And then I think that was 4 squared minus 1 for f. Let me just see, yeah. Okay, so remember back to Math 10 when we did rational expressions. So we want to factor to simplify if we can. Okay, which we can. So two numbers that multiply to negative 8 add to negative 7 are negative 8 and positive 1. So negative 4, so that's going to be negative 8, positive 1. And then this is a difference of squares. And then those divide out. Now, in terms of your domain, so it was all real numbers, but then remember we need to go back and look at when f equals 0. And that occurs when x is negative 1/2 and positive 1/2. So x cannot be plus or minus 1/2, but it can be everything else. Okay, and then this one here, g, same g, and what's h? Forget h. 2x cubed minus 3x squared, just a sec, 2x cubed minus 3x squared, minus 18x minus 8. Okay, and so we factor. We already did the numerator. Now, for this one, the denominator, we need to remember what we learned a little while ago. So we want to look for possible factors. I mean, you can use your calculator, but let's practice. Potential zeros would be plus or minus. So if we look at the rationals, so we're gonna, let's look at 1, 2, 4, 8, and then we've got to divide by plus or minus 1, 2. So potential zeros, plus or minus 1, 1/2, so you can put the plus or minus around the whole thing if you want. 1/2, 2, 1, 4, 2, 8, 4. Yeah. But you guys get to use your calculator, unlike when I was your age. And so we can go, I'll do it on my computer, 2x cubed minus 3x squared minus 18x minus 8. We'll do a standard screen. Looks like 4 works, so trace 4. It does. Okay, so we're going to factor or divide out synthetic. So 2, negative 3, negative 18, negative 8. Okay, so that's going to be x minus 4, 2x squared plus 5x plus 2, which can factor again. So x minus 4, that's going to factor to 2x, x, 4 and 1, so plus 2 plus 1. And then take a look. Both of these divide out. So we end up with 1 over x plus 2. And your domain here would be all real numbers if it wasn't dividing. What makes the denominator equal to 0 would be x. So x can't be negative 2, negative 1/2, and positive 4. All the non-permissibles from the denominator. Okay? Now, rationals, again, doing same type of thing. So simplified expression and then state the domain. So f is x minus 1 over x squared plus 4x plus 3 minus x plus 1 over x squared minus 2x minus 15. So factor that. Okay, we need a common denominator. And so multiply top and bottom here by x minus 5. And here by x plus 1. It's a good review of rationals. I'm going to expand out the numerator, so x squared minus 6x plus 5, and then x squared plus 2x plus 1 over that denominator. And then you got to collect like terms. So get rid of the brackets. Oops, get rid of the brackets. So we need a bracket. Okay, and then collect like terms. So those go to 0. Be negative 8x plus 4. Now, you can factor out negative 4, so you get 2x minus 1. Doesn't divide with the denominator, so you can just leave it like that. Now, the domain here, so the original domain of each of these, this was everything except negative 3 and negative 1. This is everything except negative 3 and 5. So it works out to be all three of those restrictions. So x cannot equal negative 3, negative 1, and 5. So we need some space for the next question. Okay. And this one's f divided by g. So we've already factored, so I'm going to put it in factored form, just to save a little bit of time here. So f is x minus 1 over x plus 3 times x plus 1. And then we're dividing by g, which is x plus 1 over x minus 5 times x plus 3. So when you think about dividing, you invert and multiply. So really you could have gone right to this step as well. So my f, and then multiply by the reciprocal of g. Notice not much divides out. You can put brackets around that if you want. The x plus 3's divide out. Oops.
So we get x minus 1 times x minus 5 over x plus 1 squared. And remember, with rationals, you don't have to expand out. You just leave it like that. So, a couple things to remember here for domain. So, obviously, in both of them, we have -3, -1, and 5. Also, though, we need to look at what makes the denominator equal to 0. So, that's the x plus 1 in the numerator. Now, saying that, it's already in the denominator of the original, so it is actually going to be just the same domain. Okay, but here's where you got to look. You got to look the denominator here, and also that numerator. That makes that g equal to 0. So now we're going to look at some absolute value. Okay, so now this one is 3 times f of x. So 3 times 4 root x plus 3 plus 2 times g of x. So that's 12 root x plus 9 plus 4 root x minus 12. Like terms is 16 root x minus 3. In terms of the domain, so this one is x greater than or equal to 0. This is x greater than or equal to 0. So overall, the domain is x greater than or equal to 0. And then just subtracting them, 4 root x plus 3 minus 2 root x minus 6. I always put brackets if I'm subtracting, so then I take that extra step to make sure I get the signs correct. Oops, that's not an x, that's a 6. So 2 root x plus 9, and again, same domain. Now we're going to multiply them together. So that is 4 root x plus 3 times 2 root x minus 6. So 4 root x times 2 root x is 8x. Minus 24 root x plus 6 root x minus 18. And then we'll have 8x minus 18 root x minus 18. Again, same domain. And then a dividing. So this would be 4 root x plus 3 divided by 2 root x minus 6. So we need to rationalize. So rationalizing, remember, you multiply by the conjugate of the denominator. We could have factored out a 2 here, but I'm just going to leave it. We'll have to do that at the end. So this is going to be 8x, I should say. 8x plus 24 root x plus 6 root x plus 18. Very similar to the last one, except different signs. And then the denominator will obviously be 4x minus 36. It's a difference of squares, right? Those are conjugates. Collect like terms. And then, so factor. Really it's going to just be a constant. So I can divide everything by, only by 2. So this would be 4x plus 15 root x plus 9. This would be 2x minus 18. Again, yeah, you can factor out a 2 there, but that's it. Nothing's going to divide out. All right, so now we know that x can't be greater than 0. or has to be greater than or equal to 0. So that's sort of our basic domain. But then we know that we can't divide by 0. So when does the denominator equal to 0? Well, you can really go to the rationalized. That's going to be when x is 9. So we can then put in the 9. Okay. And you could figure it out from the original. So 2 root x minus 6 cannot equal 0. Bring the 6 over, divide by 2, so you get root x cannot equal 3. Square both sides, so x cannot equal 9. Okay. And that's it. Good stuff. We're done.